Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, we learned question number 1 of exercise number 3.1, chapter number 3, higher order derivative and application. Question number 1 of exercise number 3.1 was totally related with the higher derivative of an algebraic function. In today's video, I am going to solve the next question, question number 2 of the same exercise, exercise number 3.1. related with the higher order derivative, but these function will totally trigonometric function. So let's move toward part number A of question number 2. Y is equal to tangent x trigonometric function is given, and that is that find y triple prime. Y triple prime means that we will differentiate the tangent x 3 times. So for the first time, you know that y prime will be, for the first time, derivative of tangent x is always equal to secant square x, which can be written as secant x whole square. Now for again differentiation, y double prime will be, the power 2 will comes to the front and we will subtract 1 in the power. So it becomes just secant x because 2 minus 1 gives us 1. Also take the derivative of this inner function. So its derivative is secant x and tangent x. So it becomes y double prime will be equal to 2 times of secant square x and tangent x. Now they test that find triple prime. So we will again differentiate for the triple prime. So y triple prime or triple time derivative will be 2 times of, over here we have two functions, secant square x and tangent x. So we will use product rule of differentiation. First function secant square x, derivative of the second function tangent x gives us secant square x, plus tangent x second function and derivative of this function 2 secant square x will be, the power will comes to the front and subtract 1 in the power, so it becomes 2 secant x. Also take the derivative of secant x, so its derivative is secant x and tangent x. Now by further simplification, y triple prime will be equal to the 2 times of secant square x. Here it is secant square x and secant square x, so it will give us a value secant raised to the power 4x plus 2 times of secant x tangent x tangent x. So it becomes 2 times of tangent square x and secant square x. So this is actually the third derivative for the part number A. Now move to the part number B, second part. It is that y is equal to ln into sin x find y triple prime. So for the first time derivative, it becomes y dash will be equal to, here it is ln of sin x, so its derivative will be 1 over, ln x derivative is 1 over x, so it becomes 1 over sin x, and derivative of sin x is cos x. So it will give us y dash is equal to cos x by sin x gives us cotangent x. Now for the second time derivative, cotangent x derivative is minus cosecant square x, which can be written as cosecant x whole square. Now for the third time derivative, it becomes y triple prime will be equal to minus the power will comes to the front and subtract 1 in the power, so it becomes cosecant x, because 2 minus 1 gives us 1 and becomes 2 cosecant x. Also take the derivative of cosecant x, which gives us minus cosecant x and cotangent x. So by simplification, it becomes y triple prime will be minus multiply minus will give us positive 2, and cosecant x and cosecant x gives us cosecant square x, and we are left with cotangent x. So this is actually the third time derivative. Now move to part number C. It tells that y is equal to under root of secant 2x find a triple time derivative of this function. So we can write it y is equal to secant x secant 2x whole raised to power 1 over 2 in this form. After this, apply the generalized power rule for the first time derivative. Y dash will be, power will comes to the front and subtract 1 in the power, so the power will becomes 1 over 2 minus 1 gives us minus 1 over 2. Also take the derivative of inner function, so its derivative is secant 2x and tangent 2x. Also take the derivative of inner function 2x, its derivative is just 2. 2 is cancelled out with 2, we are left with y dash is equal to secant 2x whole raised to power minus 1 over 2 secant 2x and tangent 2x. So y dash will be minus power 1 over 2, and here secant 2x power is 1, so it becomes secant 2x power 1 over 2 and tangent 2x. Now for the second time derivative, we will use product rule of differentiation. First function secant 2x whole power 1 over 2, and derivative of the second function will be 2 into secant square 2x, and plus because tangent 2x secant square 2x and derivative of the other function is 2 plus tangent 2x, this is the second function, and derivative of the first function using generalized power will be 1 over 2 secant 2x power minus 1 over 2, and the inner function derivative is 2 secant 2x and tangent 2x. Now after this it becomes y double dash will be equal to 2 times of here it is secant square 2x. So here the power of secant 2x is 2 and here is 1 over 2. So the power will be secant 2x whole raised to power 5 divided by 2. The power will be 5 by 2 and plus here 2 is cancelled out with 2. We are left with tangent 2x and tangent 2x, which gives us a tangent square 2x and tangent square 2x multiply secant 2x power negative 1 over 2 and here the power is 1. So 1 minus 1 over 2 gives us power 1 over 2. So it gives us secant 2x power is 1 over 2. So this is actually the second time derivative. So for the third time derivative it becomes y triple prime will be equal to the, over here we will use generalized power rule. So 2 multiply the power 5 over 2 will comes to the front and subtract 1 in the power. So it becomes a secant 2x power 3 by 2. And the derivative of inner function is 2 secant 2x tangent 2x. 2 secant 2x and tangent 2x. Plus here is it is tangent square 2x. So you will use the product rule of differentiation. Tangent square 2x first function derivative of this function. It will be 1 over 2 into secant 2x whole power minus 1 over 2. And 1 over 2 secant 2x power minus 1 over 2 in the inner function derivative is 2 secant 2x tangent 2x. So first function derivative of this function is 1 over 2 secant 2x power minus 1 over 2 secant 2x tangent 2x plus this function secant 2x power 1 over 2 and derivative of this function will be 2 into tangent 2x according to generalized power rule. 2 into tangent 2x and tangent 2x derivative will be 2 secant square 2x. So it becomes 4 secant square 2x. So for simplification y triple prime will be 2 is cancelled out with 2, we are left with 5 times of or we can multiply 5 with 2, it will give us 10 and here the power of secant 2x is 1 and here 3 over 2, so it becomes a secant 2x power is 5 by 2, 5 secant 2x power 5 by 2 and tangent 2x plus 2 is cancelled out with 2 and over here we have tangent square 2x. Tangent square 2x and tangent 2x, it will give us tangent 3x and tangent 2x, so it will give us tangent 4x. So tangent 4x. After this, secant 2x power minus 1 over 2 and here 1, so it gives us 1 over 2 and 1 over 2 will give us plus 1 and plus 1 plus 3 gives us secant 3x, secant 3 2x, so secant 3 2x. 2 plus 1 over 2 gives us 5 by 2, 5 by 2 minus 1 over 2. It will give us 2 and 5 by 2 minus 1 over 2. Here it is. Here the secant power is minus 1 over 2, so plus 1 it gives us 1 over 2 and plus 1 over 2 gives us 1 and 1 plus 3 gives us 3. So this is secant 2x, this is secant 2x. So we are just left with 4 over here. So we will write the coefficient over here. So plus 4. Now after this, this is actually the required and simplified form for the third derivative for the part number C. Now move to the part number D, tells that y is equal to 1 over x pound y power iv. Iv means that we will differentiate the given function 4 times. So let's suppose we can write the given function in simplified form just like y is equal to, here the power of x is 1. So by moving to the numerator the power will become x power negative 1. Now differentiate for the first time, so y prime will be, the power will come to the front and subtract 1 in the power. So it becomes minus 2. Now after this, differentiate for the second time, so y double dash will be minus 2 will multiply with minus 1, it will give us 2 and the power will become minus 2 minus 1 will give us minus 3. Now for the third time y triple prime will be 2 multiply minus 3 will give us minus 6 and x raised to the power minus 4. Now for the fourth time, so y power iv for the fourth time derivative it will be minus 4 multiply minus 6 will give us 24 and x raised to the power minus 4 minus 1 will give us minus 5. So the required result will be 24 divided by x raised to the power 5. This is actually the fourth time derivative. Now move to the last part of today's lecture in question number 2, part number E. Y is equal to sine into sine expand y double prime y means that we will differentiate the given function twice or 2 times. So let's suppose this sine x is equal to u. So y will be equal to sine time of u. Differentiate both sides with respect to x. So dy by dx will be derivative of sine u is actually, you know, that cos of u. And also u is the inner function, so we can write the u by dx. So we represent and put u is equal to sine x. Now differentiate both sides with respect to x. So du by dx will be equal to cos of x. So put du by dx cos x over here, so it becomes a cos time of our u. U is sin x, so it becomes cos into sin xo, and du by dx is a cos xo. We also directly differentiate this function because sin into sin x will give us cos into sin xo, and derivative of sin x is cos x. So this is actually the first time derivative y prime. For the second time, y double dash will be, let's suppose this is first function and this is a second function. So use product rule of differentiation. First function cos into sin xo, and derivative of the second function cos x is negative sin xo, and plus second function cos of xo, and derivative of this function will be, cos derivative is negative sin, so it becomes minus sin into sin xo. Also take the derivative of inner function sin x, which gives us cos xo. So by simplification it becomes y double dash will be equal to negative sin xo multiply cos into sin xo minus sin x cos into sin xo, and here it is minus and plus, so it will give us minus. So minus time of cos x and cos x, it gives us cos square xo, and after this we have sin into sin xo. So this is actually the required second time derivative for the last part number E of question number 2. With this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about FSC Part 2 Mathematics. Thank you.